Learning objectives. In this chapter, the user would learn the following in detail: management standards and models, network design issues for the project and monitoring tools, integrating tools, development tools, web-based enterprise management, network management functions, configuration management and auto discovery, configuration database and reports, abstract syntax notation 1 or ASN.1. Abstract syntax notation 1 or ASN.1. Abstract syntax notation number 1 is a standard that defines formalism for the specification of abstract data types. ASN.1 is the acronym for Abstract Syntax Notation 1, a language for describing structured information, typically information intended to be conveyed across some interface or communication medium. ASN.1 has been standardized internationally. It is widely used in the specification of communication protocols. ASN.1 is a formal notation used for describing data transmitted by telecommunications protocols, regardless of language implementation and physical representation of these data, whatever the application, whether complex or very simple. With ASN.1, the protocol designer can view and describe the relevant information and its structure at a high level and need not be unduly concerned with how it is represented while in transit. Compilers can provide runtime code to convert an instance of user or protocol information to bits on the line. ASN.1 comes into its own when the information being described is complex. This is because the language allows arbitrarily complex structures to be built up in a uniform way from simpler components, and ultimately from a few simple information types. ASN.1 is in effect a data definition language allowing a designer to define the parameters in a protocol data unit without concern as to how they are encoded for transmission. He merely states a need for an integer followed by text, followed by a floating point number, etc. They can be named and tagged such that two integers can be differentiated as meaning, file size, or record number, for example. The notation provides a certain number of pre-defined basic types such as first column, simple data types, second column, character strings, third column, useful types, first row under first column, boolean, under second column, numeric string, under third column, generalized time, second row under first column, integer, under second column, printable string, third column, UTC time, third row under first column, enumerated, under second column, teletext string, third column, external, fourth row under first column, real, under second column, IA5 string, under third column, object descriptor, fifth row under first column, bit string, under second column, graphic string, sixth row under first column, octet string, under second column, general string, seventh row under first column, null, etc. Arbitrarily complex structures can be built up from these data types using constructors such as set, open and closed curly bracket, order not significant, sequence, open and closed curly bracket, fixed order, structures, open bracket, sequence, close bracket, lists, open bracket, sequence of, close bracket, choice between types, open bracket, choice, close bracket, etc. and other useful modifiers such as optional and implicit. Subtyping constraints can be also applied on any ASN.1 type in order to restrict its set of values. This syntax can't be extensible. ASN.1 offers extensibility which addresses the problem of and provides support for the interworking between previously deployed systems and newer, updated versions designed years apart. ASN.1 sends information in any form, that is audio, video, data, etc. anywhere it needs to be communicated digitally. ASN.1 only covers the structural aspects of information, that is, there are no operators to handle the values once these are defined or to make calculations with. Therefore, it is not a programming language. ASN.1 used the concept of ABNF of valid syntax or in XSD of a valid document Its focus is entirely on valid encodings of data without concern with any meaning of data might be attached to encodings, that is, without any of the necessary semantic linkages. One of the main reasons for the success of ASN.1 is that this notation is associated with several standardized encoding rules such as the BER or Basic Encoding Rules, or more recently the PER or Packed Encoding Rules, which prove useful for applications that undergo restrictions in terms of bandwidth. These encoding rules describe how the values defined in ASN.1 should be encoded for transmission, that is, how they can be translated into the bytes over the wire and reverse, regardless of machine, programming language, or how it is represented in an application program. ASN.1's encodings are more streamlined than many competing notations, enabling rapid and reliable transmission of extensible messages. It is an advantage for wireless broadband. Because ASN.1 has been an international standard since 1984, its encoding rules are mature and have a long track record of reliability and interoperability. An ASN.1 definition can be mapped by a pre-runtime processor into a C or C++ or Java data structure that can be used by application code and supported by runtime libraries providing encoding and decoding of representations in either an XML or a TLV format, or a very compact packed encoding format. Tools on almost all operating systems support ASN.1. ASN.1 also supports popular programming languages such as Java, C, and C++, as well as older ones including COBOL. As an example of ASN.1's universality, there are tools that have been ported to over 150 different computing platforms. There are a lot of well-tested ASN.1 tools that have been used for a long time. Using such tools, they are less likely to be costly, delays in bringing new products to market, or even worse, recalling products based on new code that hasn't been sufficiently tested for flaws. ASN.1 is widely used in industry sectors where efficient, low bandwidth, low transaction cost computer communications are needed, but it is also being used in sectors where XML encoded data is required, for example, transfer of biometric information. Configuration database and reports. A configuration management database, or CMDB, is a repository that acts as a data warehouse for information technology or IT installations. It holds data relating to a collection of IT assets referred to as configuration items, or CI. It provides the descriptive relationships between such assets. Repository provides a means of understanding the composition of critical assets such as information systems, the upstream sources or dependencies of assets, the downstream targets of assets. CMDBs are used to keep track of the state of different things referred as assets, such as products, systems, software, facilities, and people, also the relationships between such assets. The maintenance of such state-related information allows for the reconstruction of such assets, and as well as for things such as impact analysis, in the cases of root cause analysis or change management. The Information Technology Infrastructure Library Framework, also known as ITIL, describes the use of CMDBs as part of infrastructure operations. In the ITIL context, a CMDB represents the authorized configuration of the significant components of the IT environment. CMDB helps an organization understand the relationships between the components of a system and track their configurations. The CMDB is a fundamental component of the ITIL framework's configuration management. CMDB implementations often involve federation, the inclusion of data into the CMDB from other sources, such as asset management, in such a way that the source of the data retains control of the data. Federation is usually distinguished from ETL, that is, extract, transform, and load, solutions in which data is copied into the CMDB. CMDBs can be used for many things, including but not limited to business intelligence, software and hardware builds, and impact analysis, both change management and incident management, and According to ITIL specifications, the four major tasks of configuration management are identification of configuration items to be included in the CMDB, control of data to ensure that it can only be changed by authorized individuals, status maintenance, which involves ensuring that current status of any CI is consistently recorded and kept updated, verification through audits and reviews of the data to ensure that it is accurate. CMDB contains and records data records that are also called configuration items. It also provides details about the important attributes of CIs and the relationships between them. CI attributes and data. Depending on the CI type or category, there are many attributes that might be captured. Number 1. CI unique identifier or identification code. Number 2. CI name or label, that is often both long names and short names. Number 3. CI abbreviations or acronyms. Number 4. CI description. Number 5. CI ownership, that is organizations and people. Number 6. CI importance. There can be many more depending on the CI types. In some cases there may be hundreds of attributes. Because attributes are defined by metadata, CMDBs also contain metadata, and thus the concept overlaps with that of a metadata repository, which is also used to more effectively run IT organizations. Configuration management addresses how the data is to be kept up to date, which has historically been a weakness of metadata repositories. Relationships between CIs. Relationships are often composed of a source CI that is related to a target CI. Semantic relationships. It is desirable to have a descriptor between the source CI and target CI that helps provide context. For example, database X is related as a component of application Y. The descriptor is also known as a predicate. Configuration item types. A configuration item type or CI type is a data type of an element or configuration item stored within the CMDB. At a minimum, all software, hardware, network, and storage CI types are stored and tracked in a CMDB. Also track business CI types in the CMDB, such as organizations, people, markets, products, and third-party entries like vendors and partners. This allows the relationships between CIs to become more meaningful and the CMDB to become stronger source for knowledge management. A key success factor in implementing a CMDB is the ability to automatically discover information about the CIs, that is auto-discovery, and track changes as they happen. Report. Configuration reports, sometimes referred to as setting reports, offer much needed information about machine. The report details all the settings of the machine. This information may be needed for troubleshooting or for reference after any changes are made to the system. We should take printout of a configuration report periodically to get up-to-date report on hand. But there have been some questions recently on the customer support forum about how to stop the report from printing when the machine is powered on. Some machines may print the report every time the machine is powered on as a default. This may not be the best option for work environment. To disable the option for printing the configuration or settings report at power on either on the machine itself or through the web interface for the machine. The instructions for disabling this feature are available on the support page for machine. Search on configuration on startup to find the solutions for disabling the feature. To find the solution for how to print the configuration or settings report by searching on configuration report on the support page for your machine. Most of the reports offered by the machine can be controlled from the control panel of the machine or through the Centerware Internet Services or CWIS. To find out information on controlling other reports, search on report for further information. We also ask for help from other Xerox printer and multifunction users on the customer support forum or by contacting your local support center. So print out a current configuration report and keep it near the machine and then find out more about all reports and some very useful information. Configuration reports helps the administrators to view the details of the configurations that are applied on users' computers and based on the configuration type. To view the reports, follow the steps given below. Number 1. Click the Reports tab to invoke the Reports page. Number 2. Click the desired report from the Configuration reports. Configuration reports includes the following reports: configuration by user, configuration by computer, configuration by type. Configuration by user. This report provides a list of users for whom configurations were applied using Desktop Central. It also provides details about the total number of configurations applied for a particular user and the last configuration and time at which it was applied. Clicking the username will list the details of the configurations applied for that user. There is an option to filter your view based on the time at which the configuration was applied or by the configuration type. Configuration by computer. This report provides a list of computers for which configurations were applied using Desktop Central. It also tells about the total number of configurations applied for that computer and the last configuration and time at which it was applied. Clicking the computer name, it will list the details of the configurations applied for that machine. There is an option to filter your view based on the time at which the configuration was applied or by the configuration type. Configurations by type. This report provides a list of configurations that have been applied on users and computers based on the configuration type. It also provides the total number of configurations that have been applied for a particular type and the last configuration and time at which it was applied. Configuration management and auto discovery. Configuration management. Configuration management is a large function inside network management. Configuration management is not just about a technology to collect device information, but also about the processes needed for network support and operations. Configuration management can be summarized as device hardware and software inventory collection, device software management, device configuration collection, backup, viewing, archiving, comparison, detection of changes of configuration, hardware or software, configuration change implementation to support change management. Some of the benefits of an effective configuration management system are downtime through rapid change impact identification, productivity improvement for making configuration changes, helps ensure compliance for device configuration, software versions, and hardware, quick impact determination of security alerts, improved visibility and accountability at all levels, improved process and approval implementation. Configuration management, or CM, is a systems engineering process for establishing and maintaining consistency of a product's performance, functional and physical attributes with its requirements, design, and operational information throughout its life. CM process is also used with IT service management as defined by ITIL and with other domain models in the civil engineering and other industrial engineering segments such as roads, bridges, canals, dams and buildings. Configuration management is the cornerstone of the network management system and of the network's life cycle. It provides control over network elements and linkage between the phases of the life cycle. Phases in the network life cycles are prepare, plan, design, implement, operate, and optimize. Network life cycle applies to the entire life of the network as well as any smaller projects that extend the network over time. A general definition for a project is anything that requires design, and all design should fit into the architecture, or the architecture should be updated as new requirements are identified. Processes are important for a successful configuration management system. ITIL provides a good framework for processes relevant to configuration management. There are more generic or general processes that are needed for configuration management in a network. Related ITIL processes. The following are the directly related ITIL processes that network configuration management supports. Configuration management including the CMDB, change management, incident management, point problem management, capacity management. Configuration management. Network configuration management is synonymous with ITIL configuration management, which defines the important elements of configuration management which are required for a network. More specifically, the Configuration Management Database or CMDB talks about relationships between configurable items or CI. The definition of a CI is about switches and hundreds of interfaces. Service management does not really address the concept of shared infrastructure very well, and as a network is shared by almost all services. Change management. Without effective configuration management, change management is somewhat pointless. Currently, many organizations implement change management on a trust basis to audit approved changes against actual configuration changes. Change management is probably the ITIL process that affects businesses the most. It provides a distinct link between IT operations and the business. It requires IT to coordinate its efforts with the business group to help ensure that the business impact is minimized or avoided. Incident management. Time to resolve. Configuration management is important for incident management. It provides up-to-date information about the network. Problem management. Configuration management is crucial for problem management. Without this information, the problem management process is difficult. Capacity management. This is specifically related to the physical capacity of the network. Inventory data provides information about the spare capacity for interfaces, ports, modules, slots, and so on. This is especially true for campus and data center management. From the work in standards, configuration templates that represent the functions of devices can be developed. The same basic template can be used for all flow switches where only the host name, IP addresses, or VLANs and so on are unique. Once these templates are developed, they can be set up within configuration management tools and allow rapid deployment and configuration baseline or auditing to verify network-wide compliance of the devices to the template. This seems like an obvious solution. It is a simple, high-value function that will ultimately save a lot of rework by the network engineering team and increase productivity. Auto-discovery. Auto-discovery is a group of software tools for detecting and collecting data on network changes and network asset changes such as changes to data files, memory and software upgrades or versions. Auto-discovery tools refer to a set of tools that collects data on a network and records any changes made to the assets. For example, HP's Network Node Manager is able to discover all equipment connected to a TCP/IP network, a Simple Network Management Protocol or SNMP. Auto-discovery capabilities of management systems typically pertain to network elements as a whole. Ability to automatically detect which network elements are connected to a network and to discover their type and physical and logical configuration. Service and network layer information, on the other hand, is in general not discovered but provisioned and provided by the organization operating the network and services. Desktop management tools may be able to collect information about Windows-based devices using interfaces like Microsoft Windows Management Interface or WMI. The auto-discovery function is just one of the many functions of these tools. Auto-discovery is used in large companies to populate configuration management databases or CMDBs. Such data is difficult to manage but may benefit the company. One example is human resources data. As soon as a configuration item or CI is manually determined and linked to an application, auto-discovery will automatically find the data and begin populating the database, possibly a CMDB. Company management, along with IT personnel, must check to see that auto-discovery is working properly. The type of check that a company uses will depend on the company's philosophy about what and how information is discovered, collected, disseminated, and made internally or externally available. During the identification phase of the configuration management process, we need to populate data into our new CMDB and capture relevant information of the assets and configuration items. Auto discovery tools are useful to get an initial inventory list of the assets or configuration items, that is CI, in our IT environment. They can also capture relevant attributes of the asset or CI. Auto discovery tools should be able to produce a report, spreadsheet or CSV file with the information that need for CMDB. We should cleanse or transform the data before loading them into the CMDB. Different tools may produce different or conflicting information and some reformatting may be needed. Cleansing and transformation is best done manually and may need some consultation with the CI owners to validate conflicting data or information produced by the tools. If that data are enough for processing, do the CMDB loading. CMDB tool would typically offer a feature or interfaces for reading the data of a spreadsheet or CSV file for loading purpose. Some tools users or vendors advocate that the auto discovery tools be closely linked to the CMDB and daily updates of the output from the tools into the CMDB be done during the normal day-to-day operations or monitoring phase of the configuration management process. Since the CMDB is supposed to maintain information of all authorized and approved changes, CMDB should maintain a definitive state of authorized or baseline configuration. In case of unauthorized changes, use the auto discovery tools to generate a report that shows the actual list of assets and the attributes deployed in the IT environment. This report can be compared against a similar report of authorized assets produced from the CMDB. Any discrepancies between the actual against the authorized are detected and appropriate corrective actions are taken. This procedure can be automated if possible, so we get an exception report each day or each week. Similarly, the above procedure can be used during the regular audit or verification activities in the configuration management process. In any case, most auto discovery tools cannot fully replace the manual and disciplined monitoring and control activities that need to be in place. The tools would not be able to produce good reports on the CI relationships, which is an important area in configuration management. They are also limited in their scope and reach, that is, those that can discover network configurations may not be able to discover desktops configuration or applications and vice versa. Auto discovery tools can help the configuration manager by reducing the effort involved in the CMDB setup, day-to-day monitoring, regular audits and verification. They should be used where feasible and used correctly. Development tools. Network development tools are the set of tools to develop structural backbones and graphical representation of network communications with the different set of subnets. The network development includes a set of tools which may be used for a variety of applications. Three major groups of tools. The first group is the network development tools. Generic networking tools are critical in many risk assessment applications, such as modeling event and fault trees and describing qualitative or casual modes of the system. The main functions of the network development tools are summarized below. Number 1. The first family of functions is related to the creation of a network and its graphical display. Number 2. Another set of functions helps the user to modify the network and change data about specific nodes. Number 3. And the third group of functions deals with the saving and loading network to or from the databases. Network Development Kit. The Network Development Kit or NDK stack serves as a rapid prototyping platform for the development of network and packet processing applications. It can be used to add network connectivity to existing applications for communications, configuration, and control. Using the components provided in the NDK, developers can quickly move from development concepts to working implementations attached to the network. The NDK is a networking stack that operates on top of the SYS/BIOS real-time operating system or RTOS. The stack can be ported to any hardware in the TMS320C6000, Cortex-A8 and ARM9 families. The NDK software package is designed to be a transparent add-on to other networks. The NDK core stack can support jumbo frames, that is package sizes larger than 1500 bytes also. The jumbo frame support can be built into an application by linking with libraries compiled for jumbo frame support. Integrating tools. System integration is defined as the process of bringing together the component subsystems into one system and ensuring that the subsystems function together as a system. The system integrator brings together discrete systems utilizing a variety of techniques such as computer networking, enterprise application integration, business process management, or manual programming. System is an aggregation of subsystems cooperating so that the system is able to deliver the overarching functionality. System integration involves integrating existing, often disparate systems. System integration, or SI, is also about adding value to the system, capabilities that are possible because of interactions between subsystems. A system integration engineer needs a broad range of skills and is likely to be defined by a breadth of knowledge rather than a depth of knowledge. These skills are likely to include software, systems and enterprise architecture, software and hardware engineering, interface protocols. Methods of integration. Vertical integration, as opposed as horizontal integration, is the process of integrating subsystems according to their functionality by creating functional entities. The benefit of this method is that the integration is performed quickly and involves only the necessary vendors. Therefore, this method is cheaper. On the other hand, cost of ownership can be substantially higher than seen in other methods, since in case of new or enhanced functionality, the only possible way to scale the system would be by implementing another. Reusing subsystems for the old functionality is not possible. Star integration, also known as spaghetti integration, is a process of systems integrating where each system is interconnected to each of the remaining subsystems. When observed from the perspective of the subsystem which is being integrated, the connections are reminiscent of a star, but when the overall diagram of the system is presented, the connections look like spaghetti, hence the name of this method. The cost varies because of the interfaces that subsystems are exporting. Time and costs needed to integrate the systems increase exponentially when adding additional subsystems. From the feature perspective, this method often seems preferable for the reuse of functionality. Horizontal integration, or Enterprise Service Bus, or ESB, is an integration method in which a specialized subsystem is dedicated to communication between other subsystems. This allows cutting the number of connections or interfaces to only one per subsystem, which will connect directly to the ESB. The ESB is capable of translating the interface into another interface. This allows cutting the costs of integration and provides extreme flexibility. With systems integrated using this method, it is possible to completely replace one subsystem with another subsystem which provides similar functionality but exports different interfaces. All this completely transparent for the rest of the subsystems. The only action required is to implement the new interface between the ESB and the new subsystem. The horizontal scheme can be misleading, however, if it is thought that the cost of intermediate data transformation or the cost of shifting can be avoided. Management standards and models. Network management is governed by a large number of protocols that supports for network models. These protocols are termed as network management standards. Protocols are some special set of rules. These rules allow computers with dissimilar operating systems, network topologies, hardware, etc. to communicate. Protocol types. Without standardized protocols for communicating data between computers would be very difficult. The key standard organizations provide a formal specification which is termed as protocols. Protocol standards are usually created in one of the following ways. De facto standard. A company creates a protocol that is adopted by other manufacturers. An example of this is IBM's SNA, that is System Network Architecture, and BISync. Industry Association. A group of companies get together with the understanding of creating an interoperable standard. It is not sanctioned by one of the formal standard bodies and may selective on their membership. Examples of this type of group are the ATM Forum and the Bluetooth Alliance. Standard bodies. Groups that are government accredited organization and immune to prosecution for collusion as long as they obey their rules. They have an open, formal process for membership, require their membership to share relevant patents on a fair, reasonable, and non-discriminatory basis. The International Telecommunications Union, or ITU, and the American National Standards Institute, or ANSI, are examples of this type of standards body. Standards. There are a large number of organizations creating standards. These organizations usually specialize in the types of standards they work on. Some of the better known standards organizations are ANSI, the American National Standards Institute; ETSI, European Telecommunication Standards Institute; T1, Community T1; ADSL, the ADSL Forum; ATM, the ATM Forum; ITU, the International Telecommunication Union; IETF, the Internet Engineering Task Force; IEEE, Institute of Electrical and Electronic Engineers; TIA, Telecommunications Industry Association. Apart from the above standards mentioned, the another two important standards, ISO and IAB, that has contributed to network management. International Organization for Standardization, or ISO, an international standards organization responsible for a wide range of standards, including those relevant to networking. This organization is responsible for the OSI reference model and the OSI protocol suite. Internet Activities Board, or IAB, a group of internetwork researchers who meet regularly to discuss issues pertinent to the Internet. This board sets much of the policy for the Internet through decisions and assignment of task forces to various issues. Some request for comments, or RFC, documents are designated by the IAB as Internet standards, including Transmission Control Protocol, bar Internet Protocol, that is TCP/IP, and the Simple Network Management Protocol, or SNMP. Network Management Protocols. The following details gives the list of protocols given by standard bodies. These protocols are used in network management. IETF, the Internet Engineering Task Force. Corresponding protocols are SNMP, MIBs, SMI, NetConf. ISO, International Organization of Standardization. Corresponding protocols are CMIS, CMIP. ITU, International Telecommunication Union. Corresponding protocols are Telecommunications Management Network, or TMN. W3C, World Wide Web. Corresponding protocols are Consortium XML Technologies. DMTF, Distributed Management Task Force. Corresponding protocols are WBEM, CIM. OASIS, Organization for the Advancement of Structured Information Standards. Corresponding protocols are Web Services Distributed Management, or WSDM. TMF, Telemanagement Forum. Corresponding protocols are ETOM and ITIL, OMG, Object Management Group. Stages of network management. All areas of network management follow the four basic stages. They are as follows. Policy formulation. This defines the normal operating conditions and expectations for the network. Monitoring. Monitoring collects the status of the network to see if it is following the policies formulated above. Analysis. Analysis determines whether the network is operating correctly or not. If network is not working properly, it determines the cause of the problem and finds what should be done to correct the situation. Control. This phase implements the action plans from the analysis stage to correct the behavior of the network. OSI and Network Management Model. The International Standards Organization, or ISO, created a committee to produce a model for network management under the direction of the OSI group. ISO bar OSI Network Management Model defines a common frame of reference for network management and provides an excellent framework for understanding the major functions that NMS performs. The OSI Network Management Model has 4 parts. They are organization, information, communication, and functional. Organizational model. The organization model describes the components of network management such as a manager, agent, and so on, and their relationships. The implementation of these components leads to different type of architectures. They are number 1, 2-tier model, number 2, 3-tier model, number 3, manager of managers, number 4, peer NMS. A network object called as network elements consists of hosts, hubs, bridges, routers, etc. Network objects are classified as managed and unmanaged elements or objects. The managed objects have a management process running in them, called agent. Unmanaged objects do not have agent running in them. The manager communicates with the agent in the managed object. The features of manager, agent, and managed object are given below. Manager sends requests to agents, monitors alarms, houses applications, provides user interface. Agent gathers information from object, configures parameters of objects, responds to manager's requests, generates alarms and sends them to managers. Managed object. Network element that is managed. Houses management agent. All objects are not managed or manageable. 2-tier model. In 2-tier model, agent is built into network element. For example, managed hub, managed router. An agent can manage multiple elements such as switched hub, ATM switch, etc. MDB is a physical database. The manager communicates with the agent in the managed element. Database is in the manager but not in the agent. The manager queries the agent and receives the management data, processes it and stores in MDB. 2-tier network management organizational model. 3-tier model. In 3-tier model, intermediate layer acts as both agent and manager. As manager, it collects data from network elements, processes it and stores the result in database. As an agent, it transmits information to top-level manager. An example of intermediate level is the management site could be at local site of network and pass information to remote site. 3-tier network management organizational model. Model with model or MOM. Model with model contains 2 network domains. Such network domains are managed locally and a global view of networks is monitored by managers of managers. Agent NMS manages the domain. MOM presents integrated view of domains. Domain may be geographical, administrative, vendor-specific products, etc. Web-based management project uses similar concept. Network management MOM model. Peer NMS. Network management systems use NMS to run a management process. The agent and manager devices are called agent NMS and manager NMS. The manager and agent functions are processes and not systems. Network management system acts as peers and both NMS are having dual role. Network management peer NMS model. Information model. Information model is concerned with the structure of storage of information. For example, considered how information is stored and accessed by all. A book is identified by an International Standard Book Number or ISBN. It is a 10-digit number that identifies the author and edition of the book. A figure in a book is uniquely identified by ISBN, chapter, and figure number in that hierarchical order. For example, ISBN 0-13-437708-8 refers the figure 1 of chapter 3 of the book James F. Couros and Keith W. Rose computer networking, a top-down approach featuring the Internet. Pearson education. Thus, a hierarchy designated ID, open curly bracket, ISBN, chapter, figure number, closed curly bracket, uniquely identifies the object which is a figure in the book. Here, ISBN, chapter, figure number define the syntax or format of the information associated with the figure, and their meanings in the dictionary would be the semantic associated with them. The representation of the objects and information relevant to their management form the management information model. SMI and MIB of information model. The representation of objects and information relevant to their management form informational model. The information on network components is passed between agent and management process. The information model specifies the information base to describe managed object and their relationship. For this purpose, SMI, that is structure of management information, and MIB, that is management information base, is used. MIB is used by both agent and management process to store and exchange the information. The MIB associated with agent is called agent MIB, and MIB associated with manager is defined as manager MIB. Some facts about SMI and MIB is summarized below. Structure of management information. SMI defines for a managed object by using the information like syntax, semantics, and additional information such as status. For example, Management Information Base or MIB. Information base contains information about objects and are organized by grouping of related objects. It defines relationship between objects. It is not a physical database. It is a database that is compiled into management module. Communication model. The communication model deals with how the management data is communicated between the agent and manager process. It is concerned with the transport protocol, the application protocol, and commands and responses between peers. Network management communication model. The applications in the manager module initiate requests to the agent in the Internet model. It is the part of the operations in the OSI model. The agent executes the request on the network element, that is managed object, and returns responses to the manager. The notifications or traps are the unsolicited messages such as alarms generated by agent. Functional model. The functional model addresses the network management applications that reside upon the network management station or NMS. ISO has contributed a great deal to network standardization. The network management model is the primary means for understanding the major functions of network management systems. This model consists of 5 conceptual areas. They are performance management, configuration management, accounting management, fault management, and security management. Network design issues for the project and monitoring tools. Network design issues for the project. Network designers ensure that our communications network can adjust and scale to the demands for new services. To support our network-based economy, designers must work to create networks that are available nearly 100% of the time, and the network designers are advised to follow the following constraints. Fault-tolerant communication. Due to the deployment of sensor nodes in an uncontrolled or harsh environment, it is not uncommon for the sensor nodes to become faulty or unreliable. This unreliability makes networks split, then some nodes cannot communicate other nodes. Thus, the framework can be resilient to the advent of faulty nodes. Low latency. The framework has to detect and notify the events quickly as soon as possible. Management at a distance. Sensor nodes will be deployed at our door fields such as subway station. The managers or operators to manage the network should provide an indirect remote control or management system. Scalability. A system whose performance improves after adding hardware proportionally to the capacity added is said to be a scalable system. The number of sensor nodes deployed in the sensing area may be in the order of hundreds or thousands or more. Any routing scheme must be able to work with this huge number of sensor nodes. Scalability in sensor networks can be measured in various dimensions. Transmission media. In a multi-hop sensor network, communicating nodes are linked by a wireless medium. The traditional problems associated with a wireless channel, for example fading, high error rate, may also affect the operation of the sensor network. Coverage problems. One fundamental problem in wireless sensor networks is the coverage problem, which reflects the quality of service that can be provided by a particular sensor network. The coverage problem is defined from several points of view due to a variety of sensor networks and a wide range of their applications. Network scale and time varying. Characteristics of WSN are energy constraints. Sensor nodes operate with limited computing, storage, and communication capabilities. Depending upon the application, the densities of the WSNs may vary widely. The behavior of sensor nodes are dynamic and highly adaptive, as the need of self-organize and conserve energy forces sensor nodes to adjust the behavior constantly in response to their current level of activity. Furthermore, the sensor nodes may be required to adjust the behavior in response to the erratic and unpredictable behavior of wireless connections caused by high noise levels and radio frequency interference to prevent severe performance degradation. Issues regarding project. Project Flamingo, a multidisciplinary joint research project. The major goals of this project, which is called Flamingo, flexible multi-wavelength optical local access network supporting multimedia broadband services, are gaining knowledge on optical networking technology, investigate and devise novel and creative concepts which are more suitable for such a technology, and to study how integrated services can be supported. The project is implemented from three disciplines: device technology, design and realization of key system components to access and reuse optical channels; physical layer techniques, to investigate physical network topologies and the implementation, and to optimally use and match the capabilities of optical device technology and protocol techniques. Protocol and networking design, to devise protocol mechanisms to effectively exploit the abundant bandwidth of the multi-wavelength networks for the delivery of diversity of broadband communication services. From the perspective of the traditional layered network models, the scope of this work ranges from the physical layer to the network layer. Disciplines 1 and 2 are related to this layer. Discipline 3 is related to both data link layer and network layer. The physical layer is concerned with transmitting raw bits over a communication channel. The main task of the data link layer is to take a raw transmission facility and transform it into a line that appears free of undetected error to the network layer. The network layer is concerned with getting packet from the source all the way to the destination. Protocol and networking design issues. The allocation of multiple channels among a multiple city of multimedia users according to the range of services varies its characteristics, guarantees and data rates. It involves new challenging network management and control issues. The most important is implementation of this project involves the following issues: the design of the management and control architecture in order to provide a framework for the various control and management functions. Examples of such a functions are call acceptance control or CAC, resource management, routing of virtual connections, wavelength allocation or deallocation, wavelength routing, dynamic reconfiguration, restoration, and performance management. High-level control mechanisms that perform the need expressed by users wanting to set up a communication sessions. Example, multimedia multi-party call. Interpret them and translate them into requirements for the network resources. Low-level control mechanisms allocates specific resources, for example bandwidth, on a wavelength buffer, and maintain the presence of false and potential congestion and the sharing of resources among various sessions. Wavelength assignment strategies that allow the network configuration, which may be composed of many arbitrary virtual network topologies, to be dynamically reconfigured. Besides wavelength reallocation in case of faults, The logical topology of the network can be controlled to dynamically adapt to the actual traffic demands and communication patterns. Optical networking and the internet services are fundamental that the architecture mechanisms and strategies mentioned above be simple, generic, flexible, and scalable to accommodating upgrades. Enable the network to interoperate with IP-based networks, the design of new services or protocols at the network layer. The main reasons for the Internet Protocol or IP's tremendous success are its flexibility and simplicity. An end user wants to transmit data to another end user. The end user then requests for a connection call specifying the QoS it desires from the network. Upon receiving it, the network, number 1, look up a route that is likely to give the user the QoS. Number 2, tries to reserve resources along the chosen route in order to be able to meet the 8 users QoS. Number 3, setups the connection. Once the connection is established, the end user can start sending data. From this scenario, the following high-level aspects can be concluded. Users must be able to specify their needs. The network must be able to take users' needs, that is quality of service parameters, into account during route calculation. The network must be able to dynamically reserve resources in advance. The network must be able to take proper delivery actions for differentiate services. Network monitoring tools. Network administrators' important job is to monitor the network for performance, traffic usage, faults, and availability, and to respond quickly to issues. A network monitoring tool is a software-based or a software-hardware combination that watches the network from end to end, collecting data on hundreds of performance metrics, among them bandwidth, latency, responsiveness, and CPU use of host. A comprehensive network monitoring foundation tracks the network's behavior and issues alerts when it exceeds a performance threshold. That is, whether the network performance is dipping below an acceptable level or when network traffic spikes. Most network monitoring products work well for typical small to mid-size networks, whether wired or wireless. For complex networks like enterprise networks and distributed environments should need a comprehensive platform that offers visibility into physical and virtual servers. Wide area network, that is WAN links, or software-defined network SDN architecture, cloud-based services, network-based applications, and the increasing number of mobile devices that connect to the network. A comprehensive network monitoring product should be able to detect, monitor, and analyze a network and its devices in real time, enabling an admin to respond based on warnings and alerts. At a minimum, tool should be at least moderately easy to implement and configure, and it should support multiple vendor devices. Some of the network monitoring tools are as follows. Network Performance Monitor speeds network troubleshooting, monitors response time availability and performance, calculates network latency, automatically discovers and maps network devices. Bandwidth Analyzer detect, diagnose, and resolve network performance issues, track response time, availability, and uptime of SNMP-enabled devices, analyze and monitor network bandwidth and traffic patterns, graphically display network performance metrics in real time. NetFlow Traffic Analyzer monitors network bandwidth and traffic patterns, identifies users, applications, and protocols consuming bandwidth, highlights IP addresses of top talkers, analyzes Cisco NetFlow, Juniper, JFlow, and other flow data. IP Address Manager centralized IP infrastructure management and monitoring, proactively monitors your IP resources with alerts and reports, active IP address conflict detection and preventive alerts, delivers real-time dashboard visibility along with historical IP tracking. Network Configuration Manager enables bulk change deployment to thousands of devices, performs automatic scheduled network configuration backups, protects against unauthorized and erroneous network changes, detects and reports on network compliance policy violations. Response Time Viewer analyzes a packet capture, that is PCAP, file to help you determine if it's the network or the application. Network device monitor any statistic on any SNMP enabled network device using a desktop monitor board. Network management functions configuration. Configuration management is an essential operational capability. It is foundational for other network management functions and crucial for service management. Network management functions are popularly characterized as FCAPS, which is the acronym for Fault, Configuration, Accounting, Performance and Security. In enterprise management, FCAPS is a standard ISO telecommunications management network model. The 5 FCAPS domains clearly define the key areas of network management operations. Number 1. Fault management. The network issues are identified and rectified. Preventive steps are taken to avert their occurrence or reoccurrence. This ensures operability of the network and minimal downtime. Fault management involves recognizing, isolating, rectifying, and logging the faults occurring in the network. Network availability is ensured by trend analysis for error prediction. Number 2. Configuration management. Configuration management deals with collecting and storing configurations from network devices, simplifying device configuration, tracking configuration changes, and provisioning circuit pathways through non-switched networks. The routine or everyday operations are monitored and controlled. It involves coordination of hardware and software changes, new programs and equipment, removal of disused systems or programs, and modification of existing systems. Number 3. Accounting management. Optimal distribution of resources among enterprise users is determined in this domain. Cost efficiency is achieved through effectively using available systems. Accounting management ascertains appropriate billing of the users. It is aimed at gathering statistics of usage for the benefit of the users. Number 4. Performance management. The network's overall performance is managed by gathering and analyzing data performance. The current efficiency of the network can be determined and the network can be enhanced accordingly for future performance. Levels of throughput, utilization, error rate, and latency, that is response time, are addressed by network performance management. Number 5. Security management. The network is protected from unauthorized access and issues such as spoofing, hacking, etc. Security management involves authentication, encryption, and authorization of data security. User information is also made confidential. FCAPS is an ISO model and stands for the fault, configuration, accounting, performance, and security functions that are required to manage a network. Network management functions. The network management functions can be grouped as follows. Alert functions. Function description. Net alert raise notifies all registered clients that a particular event has occurred. Net alert raise EX simplifies notifying registered clients that a particular event has occurred because unlike net alert raise EX does not require a std_alert structure. API buffer functions. Function description. Net API buffer allocate allocates memory from the heap. Call this function when capability with the net API buffer free function. Net API buffer free frees memory allocated by the net API buffer allocate function and other network management functions. Net API buffer reallocate changes the size of a buffer allocated by a call to the net API buffer allocate function. Net API buffer size returns the size in bytes of a buffer allocated by a call to the net API buffer allocate function. Azure Active Directory Join Information functions. Function description. Net free AAD join information frees the memory allocated for the specified dsreg_join_info structure which contains join information for a tenant and which you retrieved by calling the netGetAAD join information function. NetGetAAD join information retrieves the join information for the specified tenant. This function examines the join information for Microsoft Azure Activity Directory and the work account that the current user added. Directory service and domain join functions. Function description. Net add alternate computer name adds an alternate name for the specified computer. Net create provisioning package provisions a computer account for later use in an offline domain join operation. Net enumerate computer names enumerates names for the specified computer. Net get joinable OUS retrieves a list of organizational units or OUS in which a computer account can be created. Net get join information retrieves join status information for the specified computer. Net join domain joins a computer to a workgroup or domain. Net logon set service bits notifies the net logon service of the running state of the services on a domain controller. The caller must be running in the context of either the local system or the local service account. Net provision computer account provisions a computer account for later used in an offline domain join operation. Net remove alternate computer name removes an alternate name for the specified computer. Net rename machine in domain changes the name of a computer in a domain. Net request offline domain join executes locally on a machine to modify a Windows operating system image mounted on a volume. The registry is loaded for the image and provisioning blob data is written where it can be retrieved during the completion phase of an offline domain join operation. Net request provisioning package install executes locally on a machine to modify a Windows operating system image mounted on a volume. The registry is loaded from the image and provisioning package data is written where it can be retrieved during the completion phase of an offline domain join operation. Net set primary computer name sets the primary computer name for the specified computer. Net unjoin domain unjoins a computer from a workgroup or a domain. Net validate name verifies the validity of a computer name, workgroup name or domain name. Get functions. Function description. Net get any DC name returns the name of any domain controller for a domain that is directly trusted by a specified server. Net get DC name returns the name of the primary domain controller or PDC for the specified domain. Net get display information index returns the index of the first display information entry whose name begins with a specified string or alphabetically follows the string. Net query display information returns user, computer or global group account information. Group functions. Function description. Net group add creates a global group. Net group add user adds one user to an existing global group. Net group del removes a global group whether or not the group has any members. Net group del user removes one user name from a global group. Net group enum lists all global groups on a server. Net group get info returns information about a particular global group. Net group get users lists all members of a particular global group. Net group set info sets general information about a global group. Net group set users assigns members to a new global group, replaces the members of an existing group. Local group functions. Function description. Net local group add creates a local group. Net local group add members adds one or more users or global groups to an existing local group. Net local group del deletes a local group, removing all existing members from the group. Net local group del members removes one or more members from an existing local group. Net local group enum returns information about each local group account on a server. Net local group get info returns information about a particular local group account on a server. Net local group get members lists all members of a specified local group. Net local group set info sets general information about a local group. Net local group set members assigns members to a local group. Message functions. Function description. Net message buffer send sends a message to a registered message alias. Net message name add registers a message alias in the message name table. Net message name del deletes a message alias from the message name table. Net message name enum lists all the message aliases stored in the message name table. Net message name getInfo returns information about a particular message alias in the message name table. Net file functions. Function description. Net file close forces a resource to close. Net file enum returns information about open files on a server. Net file getInfo returns information about a particular opening of a server resource. Remote utility functions. Function description. Net remote computer supports. Queries the redirector to retrieve the optional features that a remote system supports. Net remote TOD enables applications to access the time of day information on a remote server. Schedule functions. Function description. Net schedule job add submits a job to run at a specified future date and time. Net schedule job del cancels a range of jobs queued to run on a computer. Net schedule job enum lists the job queued on a specified computer. Net schedule job getInfo returns information about a particular job queued on a computer. Get net schedule account information retrieves the AT service account name. Set net schedule account information sets the AT service account name and password. Server functions. Function description. Net server disk enum returns a list of local disk drives on a server. Net server enum lists all visible servers of a particular type or types in the specified domain. Net server getInfo returns configuration information about a specified server. Net server setInfo sets the operating parameters of a server. Server and workstation transport functions. Function description. Net server computer name add binds an emulated server name to each of the transport protocols on which a server is active. Open bracket combines the functionality of the net server transport enum function and the net server transport addx function. Close bracket. Net server computer name del disconnects each network transport protocol from an emulated server name set by a previous call to the net server computer name add function. Net server transport add binds the specified server to the transport protocol. Open bracket. This function supports only the server underscore transport underscore info underscore 0 information level. Close bracket. Net server transport add ex binds the specified server to the transport protocol. Open bracket. This extended function supports the server underscore transport underscore info underscore 1, server underscore transport underscore info underscore 2, and server underscore transport underscore info underscore 3 information levels. Close bracket. Net server transport del disconnects the transport protocol from the server. Net server transport enum enumerates the transport protocols managed by the servers. Net wksta transport enum lists the transport protocols that are managed by the redirector. Use functions. Function description. Net use add creates a connection between a local computer and a server. Net use del ends a connection to a shared resource. Net use enum lists all current connections between the local computer and resources on remote servers. Net use getInfo returns information about a connection to a shared resource. User functions. Function description. Net user add adds a user account and assigns a password and privilege level. Net user change password changes a user's password for a specified network server or domain. Net user del deletes a user account from the server. Net user enum lists all user accounts on a server. Net user get groups returns a list of global group names to which a user belongs. Net user get info returns information about a particular user account on a server. Net user get local groups returns a list of local group names to which a user belongs. Net user set groups sets global group memberships for a specified user account. Net user set info sets a password and other elements of a user account. User models functions. Function. Description. Net user models get returns global information for all users and global groups in the security database, which is the Security Accounts Manager or SAM database, or in the case of domain controllers, the Active Directory. Net user models set sets global information for all users and global groups in the security database. Validation functions. Function. Description. Net validate password policy free frees the memory that the net validate password policy function allocates for the output ARG parameter. Net validate password policy enables an application to check password compliance against an application provided account database and verify that passwords meet the complexity, aging, minimum length and history reuse requirements of a password policy. Workstation and workstation user functions. Function. Description. Net wksta get info returns information about the configuration elements for a workstation. Net wksta set info configures a workstation. Net wksta user enum lists information about all users currently logged on to the workstation. Net wksta user get info returns information about one currently logged on user. Net wksta user set info sets the user specific information for the configuration elements of a workstation. Web-based enterprise management. Web-based enterprise management or WBEM comprises a set of systems management technologies developed to unify the management or distributed computing environments. WBEM is based on Internet Standards and Distributed Management Task Force, that is DMTF, open standards. Common Information Model or CIM infrastructure and schema. CIM-XML. CIM operations over HTTP. WS-management for web services. Although the name labels WBM as web-based, it is not necessarily dependent on any particular user interface. Other systems management approaches include remote shells, proprietary solutions, and IETF standardized network management architectures like the SNMP and NetConf. WBEM allows the management of any element in a standard and interoperable manner. WBEM provides the technology underlying different management initiatives in information technology. Desktop management or DASH, network management or NetMan, storage management or SMI, systems management or SMASH, virtualization management or vMan. Architecture. WBEM architecture, the components which lie between the operator trying to manage a device, that is to configure it, turn it off and on, collect alarms, etc., and the actual hardware and software of the device. The operator will invoke some form of graphical user interface, that is GUI, browser user interface or BUI, or command line interface or CLI. The GUI, BUI or CLI will interface with a WBEM client through a small set of application programming interfaces or APIs. This client will find the WBM server for the managed device that is typically on the device itself and construct an XML message containing the request. The client will use the HTTP or HTTPS protocol to pass the request, encoding it in CIM-XML to the WBM server. The WBM server will decode the incoming request, perform the necessary authentication and authorization checks, and then consults the previously defined model of the managed device to see how to handle the request. This model provides the power of the architecture. It represents the pivot point of the transaction, with the client simply in the model and the model interacting with the real hardware or software. The model uses the Common Information Model Standard. The DMTF has published many models for commonly managed devices and services, IP routers, storage servers, desktop computers, etc. For most operations, the WBM server determines from the model that it needs to communicate with the actual hardware or software. So-called providers handle the interaction. Small pieces of code interface between the WBM server and the real hardware or software. Because the interface is well defined and the number of types of call is small, it is normally easy to write providers. In particular, the writer of the provider knows nothing of the GUI, BUI, or CLI used by the operator. WBM specifications. Mappings. URI or WBM URI mapping specification 1.0. XML or XML CIM as used in CIM-XML. XML or WS-CIM as used in WS-management. UML. Protocols. CIM-XML, WS-management, CIM-RS. Discovery. SLP or WBM discovery using SLP template. Query language. CQL or CIM query language 1.0. FQL or filter query language 1.0. WBM implementation support. The following are various stages of implementation for a device manufacturer or service provider of WBM architecture. Firstly, the model. This is normally done by extending as necessary one of the standard models published by the DMTF. Then the BUI, GUI or CLI. The client and the server usually do not need to be written because there are many open source and commercial implementations available. Then the providers. In summary, the WBM architecture allows the manufacturer of a device or developer of a service to provide a standards complaint management interface to that device simply and cheaply. Conclusion. In this chapter, we have covered the following in detail: management standards and models, network design issues for the project and monitoring tools, integrating tools, development tools, web-based enterprise management, network management functions, configuration management and auto-discovery, configuration database and reports, abstract syntax notation 1 or ASN.1.